Algebra II, 3.6c, graph equations using slope-intercept form. So this is our third part to lesson 6, 3.6c. If you haven't seen the previous videos for chapter 3, you may get confused. And A and B are in this video's description. You can just click on them, okay? So we can graph equations in slope-intercept form by setting the equation so it solves for y. If we have 5y minus 20 equals negative 3x, we can use the addition property of equality to get rid of this minus 20, this negative 20 here, by adding 20 to each side of the equation, creating a zero pair here, right? It eliminates it. It adds it to this side, and we have 5y equals negative 3x plus 20. All we have to do is use the multiplication property of equality to divide each side and each term by the 5. That gives us our buddy, the invisible 1 right here, right? And we have a negative 3/5 as our slope, our rise over our run, and 20 divided by 5 is a positive 4. That's where it's going to hit the y-axis at 4. That's slope-intercept form. So the equation 5y minus 20 equals negative 3x, our equation that we had, ends up being graphed like this. We plot the 0, 4 coordinates for our y-intercept because we know it's going to be at 4, okay? So that's right there. And the other thing we know is this is a negative slope, so it's going to fall to the right. So we know our line is going to come down this way. So our rise is going to be a negative 3. So we're going to go down 3. So we're going to go 1, 2, 3. And our run is going to be a 5. 1, 2, 3, 4, 5, and we get the point 5 for x and 1 for y right here, and we can draw our line. We can graph the equation, see? We just plot that 0, 4 for the where it hits the y-axis, that y-intercept b, and we count the rise and the run to crossed lines that it will equal the rise and the run. And we looked for where the lines cross, okay? See that? Came down 3, came over 5 for the rise and the run, all right? So I want you to remember that if the line rises to the right, it's a positive slope, see? And if it falls to the right, then it's a negative slope. So let's take a look at these very carefully. This is going upwards. So just by looking at this line, we know that it's going to be a positive slope. And we can look at where it hits the y-axis. It hits it about 1 1/3, doesn't it? It's not quite a half. And we can find another point where it crosses, like right here. You want to get it where it crosses perfectly, see? If we get it to where it crosses here, that makes it hard again because we don't know what fraction that actually is. Is that a third? Is that a fourth? Is that 2/5? We're not quite sure. But if we go to exactly where the lines are crossing, we know the exact point. See that? So this would be a slope of 2/3 because I've got a rise of 4 and a run of 6. We know it's positive, it's rising. And we know we've got y equals 2/3 x. Here's the slope. And it's hitting the y-intercept b at positive 4/3, see? And we could find x if we wanted to, couldn't we? We could find a point for x by doing this. And for the negative one, well, because it's falling, we know that it's a negative slope. So all we have to do is find some points to make our right triangle, because it makes a right triangle, doesn't it? On either one, it makes a right triangle. And actually, this is the hypotenuse, isn't it? And this is a leg, and this is a leg. Remember that from last year? So we can come down 3, 1, 2, 3. And to finish our right triangle, we can go 1, 2, 3, 4 to right here. And then we have a negative 3 over 4, so our slope is negative 3/4. We could see where it's hitting the y-axis right at 2. So we could write a slope-intercept equation. We could write y equals negative 3/4 x plus 2. And by graphing using slope-intercept form, It's useful when the equation can be easily transformed into slope-intercept form by using the addition and multiplication properties of equality, right? And the y-intercept is an integer. It's a positive or a negative. So standard form of an equation looks like this. Point slope form looks like this. And then slope-intercept form looks like this. And we could change either one to the other, see? Just remember that we transform equations by using the addition and multiplication properties of equality, and when we do that, we always use the addition property first, then the multiplication property, okay? So like in this one, we used the addition property first to eliminate that negative 20 there, then we use the multiplication property to isolate the y by dividing each term by that 5. See? I could have multiplied by the reciprocal, but if you saw the last video, you know that if there's no fractions here, we don't have to do that. We could just divide each side by the coefficient, okay? All right, so those videos are in the description of this video, so you could just click on them and watch them, okay? So if you haven't seen videos A and B, you want to watch those so you don't get confused, all right? You don't want to walk into the middle of a movie and not know what's going on. You want to start from the beginning, right? Our next video is 3.6D. It's the 4th video in Lesson D. And it's going to be about finding the standard form of a linear equation, and I've got a theorem for you. And in this description is going to be a link to the Algebra II playlist so you can study, and an Algebra I chapter, Graphs and Linear Equations playlist, so you can study and catch up if you're confused. All right? Okay, we're going to continue on, and we're going to go to the last lesson, the last video of this lesson 6. I'll see you there. Bye.